Hey guys, in this video we'll be looking at parallel lines and perpendicular lines. We'll be comparing between the two, and at the end of the video I will do some practice examples just to go through some of the commonly asked questions. So stay tuned. First, let's do a quick recap of how to find the gradient of a graph. Here we look at the gradient of a straight line, and the gradient of a straight line is the steepness of the line. So how do we get a measure of the steepness of the line? We use the tangent of the angle that is formed between the line and the positive x-axis. So what that is simply is opposite over adjacent. So we get y2 minus y1 here. The length here will be y2 minus y1, and the length here will be x2 minus x1. So our gradient is y2 minus y1 over x2 minus x1. Parallel lines are lines that are moving in the same direction. So they have exactly the same steepness. They have exactly the same gradient. It doesn't matter which direction, and the length of lines doesn't matter as long as they are in the same direction. This is an example of parallel lines. They are moving in the same direction. They have exactly the same steepness, the same gradient. These two are also parallel lines. They have the exact same gradient. The length of the line doesn't matter. It doesn't have to be the same. As long as they have the same gradient, they are parallel lines. Perpendicular lines look like this. The angle that is formed between the lines is 90 degrees. And the product of the gradients of the two lines, that means m1 times m2, is equals to -1. As long as the product of the two gradients of the lines is equals to -1, they are perpendicular. And again, it doesn't have to be in this orientation. It can be in any direction, like this, or like this, or even like this. They don't have to be crossing. As long as the product of the gradient gives us -1, they are perpendicular. Let's go through an example. Given that points P, Q and R, points are given, are vertices of a triangle such that angle PQR is 90 degrees. Find the value of B. So it's always helpful to sketch. So when we sketch this, we don't have to sketch the location accurately. We don't have to sketch it on y-axis and x-axis. We can just give a rough sketch. Now we know that it's a right angle triangle. And the right angle is at PQR. So PQR is right angle here. So we don't need to sketch this accurately again. This is just a rough sketch, and we can label the points. So P is -1, 0, Q is 4, 6, and R is 10, B. Now they want us to find the value of B. Since this is 90 degrees, since there's a right angle here, we know that PQ is perpendicular to QR. This is the first thing that we can get from the information that's given to us. When two lines are perpendicular, the product of their gradients will be -1. That means gradient of PQ multiplied by gradient of QR will give us -1. And how do we find the gradient of PQ? Remember, y2 minus y1, x2 minus x1. And in this case, it doesn't matter which you choose as y2, which you choose as y1. As long as the corresponding x is the same. That means if you have chosen, for example, here, if we have chosen P to be the 2 points, so if we say y2 is 0, then x2 must be -1. If we say y2 is 6, then x2 must be 4. As long as you maintain the pair of coordinates, it doesn't matter which is 2, which is 1. So in this case, I have a negative here, so I'd rather choose Q as 2. So in order to find the gradient of PQ, we have y2 6 minus 0 and x2 4 minus -1. When we put the negative number as the 1, then in the end we get a positive number, because negative and negative becomes positive. And for the gradient of QR, we do the same thing. So here I want R to be the 2 because I want B to be positive. So B minus 6 over x2 minus x1, 10 minus 4, 10 minus 4. And when we work this out, we get 6 over 5 is b minus 6 over 6. And we can eliminate 6 here. 6 divided by 6 is 1. And then multiply both sides by 5 in order to eliminate the 5. So 5 and 5 will be 1. 5 divided by 5 is 1. On the right, we have negative 1 times 5. So what we are left with is b minus 6 is negative 5. Add 6 on both sides to eliminate the negative 6 here. You get b is equals to 1. This is one of the common ways they can test on perpendicular lines. Now let's look at parallel lines. Given that points A, B and C are collinear, so this term here, collinear here means if we draw a line connecting all the points, it will be a straight line. We just draw a straight line and we just put in points A, B and C. It doesn't matter where you put the points. Again, we don't have to draw it accurately. We don't have to plot the points. Just sketch it out. It makes it easier to visualize. So since they are collinear, when you join all the points, they form a straight line. Line AB will be parallel to line BC. Also, line AB will be parallel to line AC. And similarly, line BC will also be parallel to line AC. So you can use any combination that you like. So here we need to find the value of P. We definitely need to include this. Let's use AB is parallel to BC. So if AB is parallel to BC, remember parallel lines have exactly the same gradient. So here the gradient of AB will be the same as gradient BC and BC. How to find the gradient of AB? So here both are negative numbers. It doesn't really matter which I choose as 2 and 1. So I've chosen B as 2. So this will be y2 minus y1. Negative 10 minus negative 4. And then 5 minus 1. 5 minus 1. x2 minus x1. Same thing for BC. So here I definitely want C to be 2 because I want the P to be positive. So y2 will be 8 minus negative 10. This is y1, and then x2 p minus x1 5. So p minus 5. Now we need to work it out. We have negative 6 over 4 equals to 18 over p minus 5. You can choose to simplify first, but I don't want to simplify first. So I get rid of 4, multiply both sides by 4. 4 divided by 4 is 1. Here we get 72. What is essentially happening is we are switching places. What is really going on technically is we are multiplying both sides by p minus 5 and dividing both sides by negative 6. But the simple version is here we can swap because here is a fraction and a fraction. So what we get is p minus 5 and negative 6 is down here. Just now we worked this out to be 1 and 72. 72 divided by negative 6 is negative 12. So we have p minus 5 is negative 12. In order to get rid of negative 5 here, we have to add 5 on both sides. And so we get P is equals to negative 7. This is a popular method of asking questions on parallel lines. So again, perpendicular lines, we have to remember the concept of the product of the gradients, which will give us negative 1. In parallel lines, the concept that we need to remember is the gradients will be exactly the same. That's it for this video, guys. I hope you've learned something. If you have, please do hit the like button to support me and my channel. And if you haven't subscribed, please do subscribe. I'll see you in the next video.